Hello students, welcome to all of you in my YouTube channel. I am Dr. Himanshu Sarkar. In my last class, I discussed some portion of the electrostatics for class 12 students. Electrostatics I discussed Coulomb's law, unit charge, etc. Now, I will discuss the relative permittivity, then electric field intensity, etc. Before that, I request to all of you to subscribe my channel so that you can see easily all of my next video contents. Now, what I told you, as per the Coulomb's law, that is the force between the two charged particles. That is, I told you, that is the force is equal to 1 by 4 pi epsilon naught into Q1 Q2 by R square. That is the force F. Epsilon 0 is called the absolute permittivity in the free space. Q1 Q2 are the charges, R is the distance, and value of 1 by 4 pi epsilon naught is equal to 9 into 10 to the power 9 SI unit. Also, I discussed in my previous lecture what is the value of epsilon 0 and what is the dimension of epsilon 0. Dimension of epsilon 0 I already discussed, and value of epsilon 0 8.85 10 to the power minus 12. Now, first let me discuss this formula is valid. This formula is valid if the two charged particles are kept in air medium. But if these two charged particles under the same condition placed in other medium, suppose water, suppose kerosene, glycerine, etc., what will happen? Then force will change. Actually, then we will consider a new term called epsilon R, that is medium dependent term called relative permittivity, or it is called dielectric constant. So, this formula is valid for if the two charged particles in air medium. This formula for air medium, F. Now, if the two charged particles are kept in other medium whose relative permittivity is suppose epsilon R, then how to modify the equation? The equation looks like this, that is epsilon, that is Fm. M stands for force in other medium other than air medium. Clear? That is what? 1 by 4 pi epsilon 0 into epsilon R. This new factor is coming here. This is a medium dependent term. Epsilon R into Q1 Q2 by R square. That is in other medium. In other medium. Say, for example, water. That is what I have done. Think. Again you think. Two charges, Q1 and Q2. I am keeping these two charges in air medium. At distance, R. Then what is the force between the two charges? This formula. 1 by 4 pi epsilon 0 Q1 Q2 by R square. Now same two charges Q1 and Q2. Suppose I am placing these same two charges in water or kerosene or glycerin like that. And if the two charges are separated by the same distance r as in the air medium, same distance r, then the new force in that medium will be what? That is Fm. That is 1 by 4 pi epsilon 0 into epsilon r into Q1 Q2 by r square. So concept clear, no problem. Now you can write down F, take the ratio F by Fm, take the ratio. This term cancel, this term cancel, this term cancel. So what you can get? F by Fm, you can get epsilon r. F by Fm is what? Epsilon r. Means what? Fm is equal to what? F by epsilon r. Now think, what is the physics behind it? That is, suppose I consider, for suppose water medium, I consider suppose value of, I consider the value of epsilon r, suppose 80. Say, in a medium, epsilon r is equal to 80. That means what is the physical meaning? What is the physical meaning of epsilon r? That is then Fm is equal to what? F by 80. What is the meaning? The force in other medium will be reduced by 80 times. It will be reduced. That is how much the force between the two charges is reduced. Force how much reduced? That is the measure of epsilon r. For example, two charges kept in the air medium at some distance. Suppose F is equal to 160 Newton. Now, what will be the force between the same two charges under the same condition, that is placed at the same distance apart, if the two charges kept in the water, whose relative permittivity value is what? 80. Then what will be the new force in the medium? Answer is what? F for medium will be what? F by 80. That is 160 by 80. That is how much? That is equal to 2 Newton. Just to think. Same two charges force. At some distance, the force was 160 Newton in air medium. Same two charges placed in the water medium with the same distance apart, the force reduced to how much? 2 Newton. So it is very interesting. How much force is reduced? That is gives the basic idea regarding the epsilon r. I think clear to all of you, no problem. Now I will discuss another very interesting factor. That is, I think very interesting factor. That is, actually all you need the SI unit. But sometimes also CGS unit is also very much important. Lots of numericals may come also from CGS unit also. SI unit though, everything is there, SI unit, but also we can discuss on CGS unit. So what are the CGS and SI unit? This is a SI unit, that is the CGS, called electrostatic unit, called electrostatic unit. How the equations modified? Suppose again I consider two charges are kept in air medium. Then what I can write down? Then F for air medium 1 by 4 pi epsilon naught into Q1 Q2 by r square. Electrostatic what will happen? This factor means this SI, this factor is what? You know, 9 into 10 to the power 9 into Q1 Q2 by r square. If I go to the air medium, and electrostatic unit, the answer will be much more simplified because this factor becomes equal to 1. So in CGS, electrostatic unit, F in here, you can write down Q1 into Q2 by R square. So this factor here 9 to 10 to the power 9, here the factor is 1. So yes, electrostatic unit is very much simplified. Here force represented as Newton. Here force represented as dyne. Here charge Q, charge in Coulomb. Here charge in electrostatic unit. I think clear? Now you may ask me the question, that is, what is the relationship of the charge in Coulomb and charge in electrostatic unit? What is the relationship? You know, for mass 1 kg means 10 to the 3 gram. 1 meter 100 centimeter. So charge, what is the relationship? Just I am writing down, that is 1 coulomb, 1 coulomb of charge is equal to 3 into 10 to the power 9 issue of charge. That's the basic idea. I think, students, all of you clear. Now I am stopping my class here. In my next class, I will discuss what is electric field,